I already kind of talked a little bit about how, we're going to use like our 30 degrees and 45 degrees to come up with signs of different angles like the 75 and the 15. All right, so the first part here is just to kind of show how the relationship of our angles exists. So it asks, is sine of A plus B equal to sine of A plus sine of A plus sine of B? So if we were to test it using, pi over 6 and pi over 3 as an example, okay? So if we start with sine of A plus B, which would be sine of pi over 6 plus pi over 3. Pi over 3 you can change to 2 pi over 6, which makes it sine of 3 pi over 6, which simplifies down to sine of pi over 2. Okay, if you need to, using your unit circle that you pulled out, what is sine of pi over 2? Hint, 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 90 degrees. Okay, it should be 1, right? Because on our unit circle, we're talking about, the point up here, which is 0, 1, and it's the y value, right? Okay, all right, so now, sine of A plus sine of B, if we were to do it without parentheses, almost like the sign kind of got distributed, what is sine of pi over 6? Okay, and if you don't have your pi over 6 on there, remember it's sine of 30 degrees.
1/2.
1/2. Love it. Okay, what is sine of pi over 3, or sine of 60 degrees? Root 3 over 2. All right, so the question is 1/2 plus root 3 over 2 equal to 1? No, it would be 1 plus root 3 over 2. Okay, so are these two things equal to each other? You would say no. Okay, so this shows us that we need the following formulas. Okay, all right, so these are the formulas that we are going to need to learn. Okay, we need to know them. I'll give you a couple of tricks to help you. Okay, number one, if I focus on, like the sine ones, one of the things that, I kind of think about here is, S stands for same. So notice that the sign stays the same. Okay, so sine, same, all right? So if it's a plus, you're adding in between your sine and cosine. Same when you're subtracting. When you have cosine, well, C can stand for change. So notice that we're changing it from a plus to a minus, and we're changing it from a minus to a plus. So that's something simple that could help you. Okay, and then when we get to tangent, I think of T as in like the top. The top of the fraction, notice that the addition stays the same, and then the bottom changes, okay? So those are just little things, okay? Mr. Mealy taught me a way that if you just say it like really, really fast, it kind of has like a nice little beat or rhythm to help you. So like for sine is sine, cosine, cosine, sine. Sine, cosine, cosine, sine. Sine, cosine, cosine, sine. And then cosine is cosine, cosine, sine, sine. Cosine, cosine, sine, sine. And then tangent, when you get to it, is tan, tan, one tangent. Tan, tan, one tan, tan. Tan, tan, one tan, tan. It has like a little beat to it, okay? All right? So, like, if you say it fast, it kind of has like a nice little rhythm to it. But the more you play around with it, the more you will learn it. See, you got a nice little tap going. Tan, tan, one tan, tan, right? The only thing that you would have to remember with some of that stuff is the signs in between, okay? So, like, if sine is sine, cosine, cosine, sine, you just need to know that the plus is in between, okay? Questions? All right, so we need to know those, all right? All we're going to do then is we're going to practice using them, okay? So, for example, in the very first one, you've got cosine of theta minus pi, all right? So, using our formula from above, okay, which you can see right here, all right? Cosine of two angles that are subtracted would be the cosine of the first one times the cosine of the second plus the sine of the first times the sine of the second. Well, cosine of theta, theta is like a variable. It's a very general term. We don't know what theta is, so we can't figure out an actual value. But cosine of pi, you can figure out. What is cosine of pi? What did you get? -1. Okay. What is sine of pi? 0. Okay. All right. If you're having trouble remembering, okay, a couple of things like in my mind, now that we've done all our graphing, okay, one of the ideas that I use, like if I'm doing, say, cosine, well, cosine starts at 0, pi over 2, at pi, it's at -1, okay? For sine, I think, oh, pi over 2, pi, it's at 0. You know, like I picture like the sine curve as opposed to remembering the unit circle, okay? All right, so then if I have sine multiplying by 0, what happens to that? That just cancels out, which means -1 times cosine theta can be simplified to negative cosine theta, and I'm done. Okay, so the idea is we are using our formula, okay, we're expanding it out, then we're simplifying any of the parts that we're able to simplify. So in this case, we were able to simplify the cosine pi and the sine pi, and then from there we simplify with the adding and subtracting, okay? So if I have the second example with the sine of alpha plus pi over 2, what would that look like if we expand it out? Sine, cosine, cosine, sine. Hint, 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 if you need it, it's right up here at the top. Good job, way to speak up. How about sine of alpha times cosine of pi over 2? Okay, this is like my A and this is like my B, right? So I did sine of alpha times cosine of pi over 2. All right, for sine, it stays the same, so I'm going to use a plus sign. And then it flips. Now I got to do the cosine of alpha and then the sine of pi over 2. And remember, alpha, theta, those are like, you know, variables, okay? They're unknowns. So we're not going to be able to simplify those, but we can simplify our cosine of pi over 2 and our sine of pi over 2. What is cosine of pi over 2? 0, okay? Which means if I take sine of alpha and multiply by 0, what do I get? I get 0, so all of that's gone, okay? And then what is sine of pi over 2? 1, okay? So therefore, I can simplify this to just cosine times 1, or just cosine of alpha, right? Questions? Anybody confused on anything? Okay, then page 2. All right, so on example 3, all they're doing is having you go the other direction, okay? So if you think about like sine of theta plus cosine 3 times theta and so on and so forth, the very first thing that you have to recognize is that this is one of your addition formulas for sine, okay? And the reason is, remember, sine goes sine, cosine, cosine, sine, whereas the cosine ones go cosine, cosine, sine, sine, okay? So when you have a mix, that's a sine, all right? Which tells me that if it's a plus, remember we said it stays the same, so this becomes sine of theta plus 3 times sine of 3 theta, therefore it's just sine of 4 theta, okay? So it's all they're doing there is just going backwards, going the other direction. Letting it sink in. Any questions on that? Okay. A lot of blank faces out there. Are we good? Okay, all right. Sometimes I worry when you're a little quiet because it's a little unusual for you guys. Okay? All right, so here you go. Here's an example of what I started the class with. You know, what if we wanted to find cosine of 15 degrees? All right, so here's the tricky part that you have to understand, okay? Number one, you have to come up with some way on your own to get 15 using numbers off of here, okay? So like, for example, what if I said find sine of 345? Well, I could do sine of 315 plus sine and plus 30. 315 plus 30. If I asked for, like the example I said earlier, 75, that's 30 plus 45, okay? If I asked for 105, how can you get a 105 using any of the angles from the unit circle? Yeah.
But subtract 30 from 135.
You could do 135 minus 30, or you could do?
Plus 45.
You could do 60 plus 45. You're both correct, okay? It's just you would be using a sum formula, you would be using a subtraction formula, okay? So as long as you're using one of the numbers that are from the unit circle, you're gonna be fine, okay? All right, so it's already kind of spelled out for you here, okay? Notice that cosine of 15 can be changed to 45 minus 30. So now using our idea of the cosine, which is cosine, cosine, sine, sine, and remember that minus becomes a plus, we take cosine of 45, cosine 30, sine 45, sine 30, simplify them down, and then we just combine like terms. Does that make sense? So a lot of that unit circle stuff, we have to kind of remember how to do. So here's an example, okay, that we'll do together. All right, we've got sine of 255. So that's a 210 plus 45. Does anybody see another way to get 255? Couldn't we do what?
300 minus 45.
300 minus 45. Okay, so this is not the only way that we could do it. Okay, I just want to point out that there are other ways. Okay, all right, so we decided to go this route. All right, so sine of an addition, what would that be? Okay, flipping back to the other page if you need it, sine of A plus B is equal to sine A cosine B plus cosine A sine B. That's what you got to remember, okay? And then the 210 is like your A, and the 45 is like your B. And that's what they were showing in the example above, okay? So the first thing is you need to understand that the 210 represents your A, the 45 represents your B, and then number two is, since you're using an addition formula for sine, you need to know what that addition formula is, okay? All right, so all we're going to do now is just plug in. So sine of 210 times the cosine of 45 plus the cosine of 210 times the sine of 45. All right, so this is why we have our unit circles out. What is sine of 210?
Negative square root 3 over 2.
Isn't sine the y value?
Yeah, my bad. Negative 1/2.
So it should be negative 1/2, okay? Multiplied by cosine of 45, which is root 2 over 2, plus cosine of 210, which is now your negative root 3 over 2, okay? And then sine of 45, which is also a root 2 over 2. Any problems with that? Okay, from here, all we're doing is we're just going to simplify. So remember that you just multiply straight across, so therefore this becomes negative 1 times root 2 is negative root 2, 2 times 2 is a 4, plus negative root 3 times a root 2 is a negative root 6, and then 2 times 2 is a 4. Okay, and then since the denominators are the same, I can rewrite it using one denominator. Okay? Questions? All right, so to check for understanding then, okay, instead of me walking you through example 6, Why don't you try example 6 on your own or with the person sitting next to you? Okay, the answer is given to you down at the bottom, so see if you're able to get it. And I'll walk around and help you if you need help. Okay, so big thing here is you got to know what, your trig functions are. And then notice that you do have to use the idea of rationalizing. And you have to remember how to rationalize by using the conjugate, okay? But it does work out, all right? All right, let's go to the third page then, okay? So here we've got sine of A is equal to 3/5, and it's telling you that it's in the first quadrant, okay? And then cosine of B is in the third quadrant, okay? So understanding that, okay? So find sine of A minus B.
The A is the 3/5 and the B is the -5/13. But if we know there's a negative, why do we need that quadrant?
Okay, all right, here we go. Okay, so we've got sine, all right, if I were to rewrite my sine formula, would you agree that it would be sine of A cosine of B, right? And then it's minus cosine of A and sine of B. Okay, all right. So to answer your question, they gave us what sine of A was. Did they tell us what cosine of A was? Okay, so if sine of A is in the first quadrant, is cosine of A going to be in the first quadrant?
Yeah.
Okay, so that's important to know, okay? They gave us cosine of B. Did they tell us what sine of B was? No. Okay, so what do we know about sine in the third quadrant?
It's going to be negative.
It's going to be negative. So to answer your question, now we know that when we plug in here, we have to use a negative value.
Okay, so it would be the
Same.
like,
So so a couple things you got to keep in mind, all right? Number one, all right, we have some information that we need to figure out, like we need to know what cosine of A is. They told us what sine of A was, but they didn't tell us what cosine of A is. There's 2 ways we taught you how to do this. Now, I know it's been an entire chapter, but does anybody remember what's one way to find cosine if you're given sine? One way, hint, hint, is, ooh, she said that we could do sine squared plus cosine squared is equal to 1. That's one way to do it. The other way to do it is you draw a picture, draw a right triangle, use the Pythagorean theorem to figure out what the other side is, okay? And if you recognize that they're using like 3s and 5s, well, you have a 3, 4, 5 Pythagorean triple. And if on the other one you notice that they're using 5 and 13, you should be thinking 5, 12, 13 Pythagorean triple. But so we can either use this idea, our trig identity, or we can draw a triangle. You want to, do you care which way we do it?
it would probably be easier just to drop the triangle, right?
Okay, so then if you're going to do that, for the A one, you're going to want to draw it in the first quadrant, right? Okay, so they gave us A sine of A, which is what, opposite, is 3, and then your hypotenuse is 5, so using the Pythagorean theorem, you should get 4. All right, so what is cosine of A? 4/5, okay? And if we're doing the other one, okay, well, now it's in the third quadrant, right? Okay, and they gave us cosine of B, which would be, what, a -5/13. And now you got to do the Pythagorean theorem and figure out that this is a -12. So now what is sine of A? -12/13, okay? So does that answer your question on why the quadrants are important? There you go, okay? So you can use the idea of drawing the triangles, okay, or you can do your sine squared plus cosine squared. And now that you know what all those missing values are, now it just goes back to just plugging in. So sine of A, they gave us, is 3/5. Cosine of B, they gave us as negative 5/13. We just figured out that cosine of A was equal to 4/5. And then we figured out the sine of A, whoops, this should have been sine of B, not sine of A. Sine of B is equal to negative 12/13. Okay? All right, after that, it just comes down to, you know, your basic math. So 3 times negative 5 is negative 15. 5 times 13 is 65, minus, and then it looks like I'm gonna have a negative, what, 48 over 65. And then change, combine them together. What's 48 minus 15? 33 over 65. And then just always think, is there a, you know, can I simplify that? Well, the only numbers for 65 are 5 and 13. The only ones for 33 are 3 and 11, so there's no common factors, so I can't simplify it. So there is my final answer. Okay? All right, see if you can do part 2. And you should have the pieces now. Okay? And if it helps, okay, I'll do like, you know, on the previous paper, okay, your goal is to get a 16 over 65. See if you can do that. If you're good with part 2, on part 3, doing the tangent one, okay, you should get a 63 over negative 16. My suggestion to you, though, is to very first, before you go and plug anything in, is figure out what tangent of A is and figure out what tangent of B is. And remember, you can figure out what tangent of A is using our nice little picture over here. And you can figure out what tangent of B is using this, or you can use the idea of sine over cosine. Whatever you need to do. So what would tangent of A be, just so that we're all on the same page? 3/4, opposite over adjacent. Okay, and what would tangent of B be? 12 over 5. And remember, it has to be positive because a negative divided by a negative, and tangent is positive in the third. All students take calculus. Okay? All right? See if you're able to get those answers. If not, I'll help you. All right, so we've got 3/4 and 12/5, right? So we've got 3/4 plus 12/5 over 1 minus, was it 3/4 times 12/5?
Yeah.
Okay, all right, so what's the common denominator for 4 and 5? 20, so I'm gonna multiply by 5 and get 15/20 plus, what, 48/20? Okay, and then 20 over 20 minus, this was a 3, right? 36 over 20.
Yeah, I instead of doing a subtraction, I did a plus sign on the bottom.
Oh, so remember the top one is the same, the bottom one's always different. So then, I already, looking ahead, know that the 20s are all gonna cancel out. So 48 plus 15 is what, 63? 20 minus 36 is negative 16. It works. Okay?